Now we'll be discussing Coulomb's law. This is a positive charge and this is a positive charge, and see, both of them are repelling each other. Same negative charge, and see, this charge Q minus Q is repelling this charge minus Q on this side, and this charge minus Q is repelling this charge minus Q on that side. But in the last figure you can see there is a positive charge and there is a negative charge, and both of them are attracting each other. So this figure is very important. The reason being, we know that like charges repel and unlike charges attract, but what will be the direction? So the direction will be along the line joining the charges. So minus Q is repelling minus Q in this direction, and minus Q is repelling minus Q in this direction. So force is along the line joining the charges. So two positive charges repel each other, two negative charges repel each other, but a positive and negative charge attract each other. Now we'll come to the equation of force. So the force of interaction between two stationary charges in vacuum is directly proportional to product of charges and inversely proportional to the square of separation. So the force between Q1 and Q2 will be K Q1 Q2 by R square, where F is in Newton, Q1 and Q2 are in Coulomb. Remember that always remember this thing, that 1 microcoulomb is basically 10 raised to power minus 6 coulomb, and 1 nanocoulomb is 10 raised to power minus 9 coulomb. You have to use the unit of coulomb. Okay, you can't use micro and nano by calculating the force. You have to convert the micro into 10 raised to power minus 6 and nano into 10 raised to power minus 9. R should be in meter, and K is a constant whose value is given by 1 upon 4 pi epsilon naught, or we can directly put the value, that is 9 into 10 raised to power 9. And always remember the SI unit. This is very important for your JE and NEET exam. The SI unit of this thing. And epsilon naught is called permittivity of free vacuum. So value of epsilon naught is 8.85 into 10 raised to power minus 12. You have to remember this unit because it will be used while calculating electric flux, and you have to also remember the SI unit. So force between two charges is given by K into first charge into second charge divided by square of distance between them. And always remember the direction of force is along the line joining the charges. So Q1 and Q2 will apply force on each other, and the force will be parallel to this line, the line that will join both the charges. So if they will repel, then the force will be away. If they will attract, then the force will be towards each other. We'll discuss this thing in numericals. So coming to the next. So if suppose the medium is not vacuum, suppose the medium is other than vacuum. So for mediums other than air or vacuum, the force becomes 1 upon 4 pi epsilon K Q1 Q2 by R square, where epsilon is epsilon naught into epsilon R, where epsilon is equal to epsilon naught into epsilon R. Epsilon naught we have already discussed, that is permittivity of free vacuum. So epsilon R is very important. It is called as dielectric constant. It is represented generally by K. It is dielectric constant. So I am taking two numericals here. In first numerical, there are two charges, 4 coulomb and 6 coulomb. They are separated by a distance of 1 meter. So force between them will be K Q1 Q2 by R square. K is 9 into 10 raised to power 9. First charge is 4 coulomb, second is 6 coulomb, and distance is 1. So the force becomes 216 into 10 raised to power 9 Newton. Now there is no vacuum between 4 coulomb and 6 coulomb, but they are filled with water, and dielectric constant of water is 80. So force will become K Q1 Q2 by R square. It is same as before, but we have to divide it by epsilon R. So the previous force was 216 into 10 raised to power 9 divided by 80. So basically, if you have force between two charges in vacuum, and if you insert both the charges in any medium, so you have to divide the force by dielectric constant of that medium. Like here I have divided it by 80. Okay. And always remember, dielectric constant of metal is infinity. This thing you have to remember, that for metals dielectric constant is infinity. Okay. Now this numerical. So there are 3-point charges are placed on the following points on x-axis. 2 microcoulomb at x equal to 0, minus 3 microcoulomb at x equal to 40, and minus 5 microcoulomb at x equal to 120. So you have to find force on minus 3 microcoulomb charge. Minus 3 microcoulomb charge is placed at 40. So if you can see, the 2 microcoulomb is positive, minus 3 microcoulomb is negative. So 2 microcoulomb will attract minus 3 microcoulomb. Attract means minus 3 microcoulomb will be pulled towards 2 microcoulomb. So the force will be on that side, and the value of force is K into first charge into second charge divided by square of distance. The distance should be converted into meters. So I have divided 40 centimeter divided by 100, and this becomes force 1. Similarly, minus 5 microcoulomb will also apply a force. Minus 5 microcoulomb is negative, minus 3 microcoulomb is negative, so this will repel it. So the force will be along that side, and the value of force will be K into first charge into second charge divided by square of distance. 120 divided by 100 becomes 1.2. See, two things are important here. You have to convert micro to 10 raised to power minus 6. It's very important. And second, the direction of force. Now, if you can see, both the forces are in the same direction. So net force will be sum of both the forces. So in this way, we can deal with force between multiple charges. Okay, Coulomb's law in vector form. Now, the most important thing here is the derivation and the formula both. So we have two charges, Q1 and Q2. Position vector of Q1 is R1, position vector of Q2 is R2, and R is a vector joining both the charges. So if I can draw the figure like this here, so R1, R2 and R. So we can write R2 to be equal to R1 plus R, because this is the resultant vector R2, and it can also be written equal to R1 plus R. It's by triangular law of vector addition. So R becomes R2 minus R1. R is a vector that is joining both the charges. So distance between both the charges will be mod R. So force will be K into first charge into second charge divided by square of distance. But this is only value. The direction will be given by unit vector. So what will be the unit vector? Vector divided by magnitude of vector. So the force becomes K Q1 Q2 R divided by mod R cube of mod R, because mod R into mod R square mod R cube. And from Newton's law, force on 1 due to 2 will be negative of force on 2 due to 1. Always remember this thing. Coulomb's law in vector form can be used when you have charges placed in coordinate axis. Okay, now this question. There are 4-point charges located on the corners of a rectangle. Find net force on Q1. So you have to find net force on Q1 charge. Remember, it is in nanocoulomb, so you have to multiply by 10 raised to power minus 9. So Q1 is positive, Q2 is positive. So Q2 will repel Q1. Repel means it will push it away. So force on 1 due to 2 will be downwards. See, Q1 is negative, Q1 is positive. So Q4 is negative and Q1 is positive. So Q4 will attract Q1. So force will be on that side. So force on 1 due to 4 on that side. And this is negative, this is positive. So this minus 8 nanocoulomb will attract 8 nanocoulomb. So force will be on that side. See, the force is on this side. So we have all three forces. So F12 is in minus j cap, F14 is in minus I cap, and for F13 you have to resolve it. So F13 cos theta in negative direction. So F13 cos theta in minus I cap, and F13 sin theta is in positive direction. So F13 sin theta becomes, F13 sin theta is basically j cap. So F13 sin theta is in j cap direction, but it's in upwards direction. Okay, so coming to the next slide. So here there are two questions. The solution to this question is this. The solution to this question is this. I want you people to solve this question and let me know if you have any doubt. And I'm sending you an assignment on your group, and even I'll upload it on my website. Or if you are not added in my group or on website, then you can WhatsApp me on 98675 30456. You can subscribe to my channel for upcoming videos so that you will not miss any video or any topic. Okay, many thanks. Thanks a lot.